Welcome to this session on so-called data science relevance in today's world. So my goal will be to cover various facets. It will be a breadth-first view of multiple facets. My promise to you is at the end of it, a lot of questions you have related to the terminologies like data science, AI, machine learning, and also their relevance in today's world, and questions related to what kind of jobs, etc., are there in this domain. All of those will be answered. So without further ado, let me start off with saying that the world we live in is talking about digital disruption everywhere. You see our classrooms getting disrupted into digital classrooms because of pandemic. We see workforce ways of working getting disrupted because of digital way of working due to pandemic. Take a field of work and we see there is digital disruption everywhere. And it is in this background, I also wanted to mention that disruption is a way of life in businesses. I'll give you anecdotal evidences from history. Look at the right side companies and the left side companies. Look at Blockbuster Video, a leader in video rentals across the globe, and look at the leader in that space, Netflix. It displaced Blockbuster because of the digital transformation, adopting a pay-per-view streaming video service concept by taking on internet. Netflix overturned classical leader called Blockbuster. Similar way, we can see how a conventional photography company, Kodak, which was the leader, could not transform by taking advantage of digital photography. And on the other hand, let's see a pioneering company like Uber pioneering the concept of travel by creating a model of no one owns anything but yet gets a ride. Similarly, conventional brick and mortar retailers like Borders had to close because they could not adopt e-commerce, whereas Amazon today is a pioneer of e-commerce where you can get anything, everything under the sun because of their pioneering work in mastering digital transformation and how to handle digital disruption. Not only that, the fact of the matter is all of these digital companies work with a very asset-light model. If you look at Facebook, it owns no content. All content is provided by you and me. Alibaba, world's largest merchant, owns no inventory. Google, world's largest software vendor, doesn't write mobile apps of its own. Uber owns no cars. Airbnb owns no property. Skype owns no telco infrastructure. Netflix owns no theaters. And yet they are the biggest in their class. And if you just look at simple Fortune 100 company list over the past 100 years, you will see the dramatic displacement of conventional with new digital age companies. So what we wanted to convey is digital first is the way to go and do business because digital disruption has transformed our way. We want to enable our journey towards becoming one of the leaders in modern world via adoption of digital transformation. And our premise is that all of this root of disruption is at few technologies, and primary technology is AI powered by data science. For example, what are works AI can do? It can lift weights, replacing labor. AI can diagnose diabetes retinopathy, replacing ophthalmologist. AI can, do billing of your shopping, replacing checkout clerk. AI can drive a car, replacing drivers. AI can save a life, calling an ambulance directly. Look at all of this. This is about dramatic transformation in which a particular task is carried out before and after AI. And that is why we feel AI is the top science and art and technology which is behind the digital disruption. So the mantra I would say is either adopt AI or be left behind. So you can be choosing to be on the left-hand side or on the right-hand side. And for being on the left-hand side, AI is one of the largest enabler of such kind of digital disruption. So, well, all of us talk about AI, but what exactly is AI? To me, it's a very simple concept. The concept is AI is mimicking of human capability of intelligence, where the intelligence is about if you can sense data, sense events around you, sense your environment, and based on the sense, you respond appropriately with an action based on the sensing. And that, my friends, is basically AI. AI is a collection of technologies. AI is a collection of algorithms, collection of all kinds of, you can say, mathematical calculations, statistical calculations, algorithms, which enable us to emulate a human being in terms of being able to sense and in response to that, being able to take some action. Let's take a very simple example. We talk about Amazon Alexa, let's say. What does Alexa do? Alexa listens to you when you give it a command. Alexa, what's the weather today? The Alexa will go take that command, scout the internet, get back with the weather of your location and the current location, what is the weather, and get back with a response. So it will respond based on the input you're giving. So it has replaced human sense of hearing and done the intelligent act of responding to the stimulus given to you by what you've spoken into it. So that's exactly what AI does. So effectively, AI is the art and science of mimicking human beings' intelligence, where specifically you respond to external stimulus with certain action after analysis of the stimulus and the data that's been given. And what does that involve? That involves extraction of patterns from data. What kind of data has been sent to me? What kind of command is given to me? What kind of data is hidden in the data which has been presented to me? All that is the analysis part of the sense. And that is where the core of AI which is coming in, which is the concept of data crunching or data analysis or data science, which is where the algorithms to extract patterns from data is commonly giving the AI systems the power of intelligence. So when you talk about AI, people talk about, oh, have we achieved all the AI that we wanted? Today we have driverless cars. Today we have very world-winning AI games like chess, Go, poker, etc. But are we really achieving the finest level of AI? The fact of the matter is there are three levels of AI. The first level, which is where we are today, though we see AI is very successful in replacing a doctor, replacing a driver, but all of that is level one, which is called as weak AI or artificial narrow intelligence. What it does is it does one task very well. On the task it was trained upon. So if you have a chess champion program, it will be having been trained on lots of chess expert games, moves, and that's how Deep Blue can beat Kasparov. But the same chess program, you go and ask it to say play Go, it will not be able to play because it's not been trained. So the same thing, a cancer detection program for, let's say, breast cancer will not be able to go and work on lung cancer data. So the reason why we have very highly performing AI programs today is because it's working on having trained a lot of data in that narrow domain. It becomes very good, very perfect in that particular domain. But to change the domain, it won't work. That's why it's called narrow. Whereas a human is very dexterous. If you take a human who is, let's say, trained in India on right-hand driving, he goes to US, picks up left-hand driving in less than a day. Let me tell you. And that's the dexterity of humans. And that kind of a dynamic adjustment and what we call as readjustment to a new environment without significant retraining is what is the power of strong AI, which is where it's expected to rival human level AI. So we have not yet reached that. That's called artificial general AI or strong AI. That may be taking 30, 40 more years to come by. And that will take tough time, because current approach to AI is about feeding tons of data in a narrow domain, make a very highly intelligent system for that domain. That's what is narrow AI. So we have not yet achieved AGI. And if you achieve AGI, it's possible that we can also visualize ASI, where super AI, where really super smart AI will emerge, which may be better than humans in every walk of life. But that we can worry about when we talk about AGI having been achieved. So why is AI in data science so important today? The fact we talked about is AI is the art and science of extracting patterns from raw data which you have sensed or raw data which you have acquired. The reason why we need to understand the importance of AI in today's world is that it is primarily driven by the fact that a lot of conventional business decision making was done by people who were experts. But that led to a lot of biases in decision making. When you talk about biases in decision making, it meant that people who took decisions were taking decisions based on the comfort level of what they were, favoring or what they would like. It may not be the best possible choice. So the enterprises over the last 30 years have started using analytics and data-driven approaches to taking business decisions. And in data-driven decision making, the idea is you identify the right problem to be solved based on data. Then you try to identify what are the sources of data you can use to help you take your decision. Then you try to clearly create a useful set of data out of it. And then you try to develop a good data science model or analytical model of that. And then once you create the analytical model, which can help you in your decision, you communicate to your stakeholders and then take the decision based on the data model which you have created. And here I have not prescribed any technology. I have not said it is statistics, it is linear regression, it is classification, and nothing. All I'm saying is there has to be a way to derive insights and patterns from raw data or raw sensory input. So what kind of data can be input? It could be structured Excel kind of data. It could be raw Twitter tweet data, or it could be raw video data, or it could be raw camera data. Doesn't matter what kind of data is, there are analytical algorithms on all of it. So this whole science of data-driven decision making is in one term called as data science, or sometimes broadly called as data analytics. We'll come to the relation between all the fields in a little while, but let me tell you the overarching umbrella of wherever you're using data for any particular analysis of pattern to help you in business decision making, it's called as analytics. So why is the current paradigm of data-driven decision making is so useful and relevant? The reason why we think such kind of a phenomena is very right at this point of time is because we're seeing lots and lots of information available to us from explosion of new data pools like Twitter, like IoT sensors, like traffic video cameras. Name it, we're generating so much data every day. Then comes the question of big compute. Big compute means today we have really big and affordable compute in our doorsteps. You remember supercomputing used to be so costly 2 decades back. Today, in a small GPU chip, we have the power of a supercomputer, which is embedded into every graphic laptop. And that's the power of bringing big compute to every person's laptop. And that is one of the big idea of why we are seeing acceleration of data analytics and AI algorithms. Then we're seeing the last of it, which is the business model around open innovation. We're seeing lots and lots of companies not necessarily keeping their innovation in-house. They're going out into the world, open sourcing innovations which are generated by the scientists so that the whole world can benefit. Today, in the world of AI, machine learning, and data science, there is a whole ecosystem of open innovation available where leading scientists from the world are making available their research and contributions available in the open world so that we can enable innovation by anyone, everyone, and being able to use it for practical business decision making. That is the reason why we're seeing that we are really sitting at the cusp of bringing data science and AI to real business decision making at this juncture. So these are the primary drivers. Without these drivers, we would not have been able to do this kind of deep penetration of AI and data science. So coming to the brass meets the road, right? Rubber meets the road. We talk about coming to brass tacks. Why is it useful? It's because today, among all the professions around computing, data science and AI are the top in demand. Interesting report, very relevant because of digital transformation. 65% of students will work in jobs that do not exist today. Reason, digital transformation. I'll give you an example. People who are expert photographers using film like Kodak film, they were not so comfortable with digital photography. So they had to lose out to people who came afresh and started working with digital cameras. They never had any legacy. So that's the kind of disruption we're talking about. So what kind of jobs are created by AI and data science? This is a very, very important slide. You think about that we talk only about a typical job like programmer or a program manager or a project manager. But think about the kind of profiles when you see in the whole journey of raw data or census to generating patterns, which is the main goal of all AI and data science. There are so many different kinds of data related jobs. Data preprocessor, these are people who will be cleaning data so that complex algorithms can be run. Data ethicist, these are people who will be at the intersection of law and, we can say, computers, where they'll try to see if the data you're using to train your models are ethically viable, are they biased against specific gender, specific race, etc. Data curator are people who will try to look at different fields. Are they related to your insight? If not, they'll try to collect more data. Business storyteller, it's about, okay, you've done a lot of analysis, but how will you convey your output? If you remember the concept of data-driven decision making, there's a concept here called as communicating your output to stakeholders to get buy-in. And that's all about storytelling. It's about, once you've done your analysis, how do you tell your story, that how it is able to help you in your business. Data protector is about people who will understand the security issues and privacy issues related to your data. Then look at the 2x2, data detective. This is the guy who will look at, is there any privacy leakage in your data? Or is there some crime you've done? Is there some data forensic act you can do to find out if there is some breach you have done? Then look at AI-enabled transformations you can do. Personal data broker will reflect what kind of personal data from you can go into different analytics. Quantum machine learning analyst is something in the future where people are expecting that quantum algorithms and machine learning algorithms will come together and you have to develop new kinds of data science in the quantum world. Let's look at another very interesting concept here from a business world, AI business development manager. It's about people who are in the sales and business development, who understand the possibilities with AI. It's not just dumb sales, right? It's about making sure that you understand the opportunities generated by AI and then communicate that to potential customers and win projects. We can go on and on. AI-assisted healthcare technician. This is about a new generation of radiologists who will not necessarily always do the entire thing on themselves. They will take the first diagnosis done of an X-ray by the AI system, and then based on that, they will endorse it or they will reject it. So their first level of processing will have been done by an AI machine. So all of this is basically talking about a really, really a short to medium to long-term kind of jobs that are going to be evolving as we speak in the world. Already we're seeing, people calling a specific kind of role like chief AI officer in a large company, chief digital officer. These are basically designations who are there to make sure that AI is absorbed in their company with a view to helping the business take drastic steps towards absorbing AI for growing proper business transformation. This is interesting. This is basically talking about 2.3 million new number of jobs AI will create by 2020. There's a lot of talk about AI killing jobs, but at the same time, there is parallelly a lot of new jobs that may be getting created by AI as we go forward. So it's a myth that only AI is responsible for killing existing jobs. But what we can think about is AI is going to reorient the workforce towards more digital friendly skills, and that may be what will be required for the future. And when you talk about the future, we're really talking about different business use cases which may be responsible for carrying out business using the power of AI and data science. So whatever I'm talking about, is it something which is somewhat far away or are they real? Today, tons of examples of practical day-to-day businesses and daily life examples where we see AI and data science already in place. Look at cashierless store. We started with Amazon starting cashierless store. Then there are lots of other companies who are starting this. For example, this is an example of, even in India, we had this example of autonomous cashierless store. Idea is just shop and go, no checkout. So it automatically checks out based on what items you picked up with IoT technologies, and then with corresponding AI technologies, you are able to understand what kind of items have gone into your basket, and then based on that you build, then you send out the bill to a payment system. It automatically gets paid by digital payment system, and you're out. So this is another interesting thing. The concept of, in the today's world of shopping, you try to first shop online, then you ship the elements to your address. On the other hand, if company Amazon wants to develop this paradigm of ship then shop, it does anticipatory shipping, means it looks at your past data of what items you bought, and based on that, it creates a pack of items. It should be sent to your home, and then you might decide to take all of them because they anyway you like because of your past experience, or sometimes if you don't want it, you can return some of them. So you see how it has turned shopping upside down. It basically, Amazon understands your shopping needs and then creates a shopping basket for you and sends it to you. Then you can choose to take it or drop some of them. This is purely an idea of using data analytics on your customer behavior and using that to provide a convenience of shopping to you. Booking a cab by Uber, Ola, etc. What is it? It's all about using AI-based technologies to understand who are the nearby riders available. Based on that, they will allocate appropriate matched driver to you. That uses a lot of location-based intelligence. Speaking to Alexa, it's basically a classic example of speech recognition of AI. We talked about sensors, right? When you talk about sensors, AI is about taking in data from many sensors. It could be spoken language which you're speaking, which Alexa like AI program is able to absorb. Or if you're trying to write something in, let's say, Google search, that will be text which is given as input. AI improves email communication, email filtering. In online shopping, customer profiling is done by almost e-commerce companies who understand what kind of items you will most likely liking, and makes your task easier by recommending items based on data science and AI algorithms. Google Maps, suggestion of real shortest paths between one location to another. All of it is happening by analyzing your past data of yours, past data of hundreds of travelers, and then looking at what can be the optimal path by looking at really prescriptive analytics done on top of this data, which has been gathered from lots and lots of users. Airline flights, you'll be surprised that pilots actually spend only 7 minutes manually flying a plane. Rest of the task is done by autopilots. Google search, biggest user of AI. They use so much of AI that they can anticipate what you want to type. They can get the best possible match for what you're typing. All of it is generated by AI at the back end, which understands the natural language text which you have input into the search. So it understands text. It understands natural language which you have written. So the part of Google search, which is very useful here, is the intelligence on natural language text, which it tries to understand. Then several usage examples in real world. Let's look at company like Vectra, what it's doing, or Darktrace. They are looking at AI in cybersecurity. They're trying to look at analyzing all the past attacks, trying to understand different malwares, trying to understand different attack data, and then creating an intelligent cybersecurity software based on that. Let's say there are other companies who are talking about applying AI in finance. For example, this company called Just Finance, which is talking about underwriting automated by using purely AI-driven analysis of your past behavior and your past consumption pattern, and then trying out the best possible underwriting offer they can give you. Similarly, there are several other examples of AI in finance industry, like there is a smart chatbot which is helping you in making financial decisions. Contract intelligence, where JP Morgan is using legal documents analysis using AI systems based on natural language processing to extract important data clauses in the contracts of the AI systems. Same way, let's look at from a retail perspective. There already we have seen examples of Amazon Go, where you said there is no concept of any checkout counter. Similarly, there are technologies like Zipline, which help retailers optimize profitability by analyzing data. Then there is Walmart, who has deployed robots to scan shelves for any kind of replenishment requirement to be fulfilling on the shelves. So all in all, you see across domains, we saw in finance, we saw in retail, we've seen tons and tons of examples of AI today in the real world being useful and getting into the action by taking input data and converting it into patterns and using that to generate the right kind of response to help in the automation of actions. Smart personal assistants, we already looked at, for example, Amazon Alexa, but that's not enough. We're seeing coming from Google Assistant, Google Now, Apple Siri, Microsoft Cortana. All these are examples of smart personal assistants powered by AI technologies where it can listen to speech, analyze speech, and respond back with speech. So all this is great, perfect. Now the question, what skills to learn, right? That's what is in minds of lots of people, lots of students. So primarily, what you need to understand that there is a Venn diagram which kinds of sums it all. It is not like everything is interchangeable. They are to major extent. But effectively, if you see, data science is the so-called science of utilizing data for extracting patterns to make decisions. And when you do that, it is a lot of times using machine learning algorithms, especially for predictive analytics. But beyond predictive analytics, you can also do simple descriptive analytics in data analysis and get decisions. For example, if you want to find trending words in Twitter, you don't need machine learning, you don't need predictive analytics. You can do a simple descriptive analytics on your tweets and analyze what are the trending keywords. Similarly, there are possibilities of AI, which is not necessarily only talking about machine learning. Machine learning does the art of allowing computers to automatically learn and infer from data so that it can predict patterns and helps in improving the pattern extraction from data automatically without necessarily programming the pattern inside. But in AI, we can do more things. Like, for example, when we talk about the Google route optimization, that's a classic AI task of optimizing using maybe constraints rather than creating a predictive analytics based on machine learning. So it is important to understand that AI is a superset of ML. Same way, there are data science which may not be AI or ML. Same way, there is AI which is ML as well as data science. So all equations are possible. But a particular kind of machine learning, which is very important, is concept of deep learning, which is a kind of machine learning which is very useful for unstructured data like speech, audio, text, NLP, computer vision, or images and videos. So for those tasks, a special kind of machine learning is very useful, called as deep learning. So when you talk of technologies which are required to be learned, you may learn data science as general with all kinds of analytics. You may learn machine learning of all kinds. You may learn deep learning as a subset of machine learning. You may learn AI, which is not necessarily only about ML, like using convex optimization, etc. So all these are basically intertwined with this kind of a Venn diagram. Most important skill, as we saw, is the concept of machine learning, which allows computers to automatically learn and infer from data. The idea of that is basically the ML process generates a model from a given data, which is like a reflection of the pattern that is present in the data. So there is no concept of programming explicitly like you do in a computer program where logic is controlled by the programmer. So in ML, humans have no control over the logic of the model or the pattern that is generated. The only way a model can be changed is by changing the data that is fed. So there is an important learning here. The important learning is as and when you give your control more to machine learning driven AI systems, the more important thing is about your processes related to data. You should have more perfect process related to your acquisition of data, cleaning of data, so that you get better output patterns out of machine learning applied on that data. So what kind of technologies are powering, whether it's AI, whether it's data science? We already saw machine learning. It's about the art of extracting patterns from data without any explicit programming. Computer vision is the art of processing images and videos to extract insights. NLP or text mining is the art of understanding text, extracting insights like sentiment analysis of tweets. Computer vision is, for example, driverless cars. Or you saw about automated checkout, right? It's all about computer vision. You try to see what object has been taken out from the shelf. Speech processing, classic example is Alexa. But beyond that, how do you model such kind of technologies in the AI paradigms? It's not necessarily that all AI is machine learning, right? So for example, when you're talking about AI for route optimization, you do what is called as planning and optimization. When you use AI for playing chess games, it's not just machine learning. You use a lot of search and constraint programming to optimize the way you let your game be played by your AI agent. So what kind of process can you help do in terms of patterns extraction from data? So this answers the question of when you say I'm extracting patterns from data, what is the pattern I'm talking about? There can be different patterns talking about, like clustering. What is it? Find similar groupings of data. So when you talk about skill you want to build the skill of clustering. Classification, it's about making sure that you want to bucket your inputs into predefined classes. For example, your mails you get, you may be treating as spam or non-spam. Predicting future. For example, if you take a current past value of stock, based on that, can you predict how the stock will open tomorrow? Text miner, basically looking at, I told you about JP Morgan legal text process, right? They look at tons and tons of legal documents, understand what are the text summaries within that, what are the important clauses. Network analyzer. This is basically very useful when you want to do analysis like epidemic networks. For example, when the administrators in the COVID, they are using contact tracing, they actually use network analysis, saying you came in contact with who all, that becomes a network graph. Then they came in contact with who all. That's how they create a network graph. Frequent sequences. This is basically what is used to identify what are the concepts which have been going together. What items have people bought together? That's what drives the whole, you see when your Amazon shopping screen, you say people who bought this also bought this. That's basically frequent sequence mining. Video sequences, video analytics. This is basically when you look at any videos, you want to see if there's some event you want to track. For example, have you seen if there is any breach of the protocol by somebody not wearing mask, for example? You want to detect and flag it off. Industrial bot. This is again a huge number of bots at customer service level, at support level coming into action today across different applications. So each of you can become a specialist. For example, these are the skills you can pick up. You can become a specialist in industrial and chatbots. You can become a specialist in contact tracing and network analysis. You can become a specialist in market segmentation and clustering. You can become a specialist in regression and prediction. You can become an NLP specialist and text miner. So like that depends upon different kinds of specialist skills you may want to pick up. It's not like one size fits all. So that's where you see that ultimately when you talk about machine learning, what kind of tasks are there? I won't go into detail, but think about there are three broad categories. First is the supervised machine learning. This talks about if you have an output variable, how do you find the relation between input data and output variable? That's called supervised learning. For example, if you have input mails coming in, you want to break it into spam or non-spam. That is where you're trying to categorize and give a value, 0 or 1. 0 for spam, non-spam is 1. Or let's say you want to break your sentiments which are coming into the text in form of tweets into neutral, positive, or negative sentiments. Or let's say you have input data of your stock from the history and you want to predict tomorrow's value. So there's an output variable which you want to predict, a class or a value. In unsupervised, there's no output variable. It's about predicting patterns within data. Like for example, when you want to group similar data in a large collection as a collection of groups, like segmenting customers. That's what clustering does. Or when you want to find out from the transactions, what item I can recommend if you already bought one. That's what the recommendation systems do. That's called unsupervised learning because there's no output variable. It's about pattern extraction data. And the last, reinforcement learning, which is coming up in a very modern way, where people say, I don't want any data. I will just learn from experience. And that is where we are seeing that there is a huge amount of effort today at creating autonomous bots which can learn from their failures and successes. That's how they're seeing that there is a lots and lots of work which is happening in the real world where there is a notion of learning from experience. And that is where we are today heading towards. So I would like to end my kind of talk by showing the power of the ultimate in this kind of analytics, which is what I call as reinforcement learning. Give me a minute. I will give you a minute to talk about this kind of a video. So when we talk about reinforcement learning, it actually talks about a particular way by which the agents learn by experience. So please pay attention to this video. There's no audio, so don't worry. Just pay attention. So I hope you got the power of reinforcement learning. So what you need to understand is, as we talk about the potential for AI-powered systems, reinforcement learning is the latest in the block, which is able to talk about acquiring intelligence on the go. And today, people are using this for lots and lots of modern applications like autonomic driving, autonomous games like chess, robots, etc. So, as I said, artificial intelligence and data science is a strategic game changer. The explosion has begun right away with us. So, parting thought, illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. Alvin Toffler. So the thought is, please put in your efforts to learn the art of data science, pick up threads on all the aspects which I said about skills, and get equipped. So instead of being eaten by AI, be on the other side where you create AI. So this is our YouTube channel where we have lots and lots of explanatory videos on different aspects of AI and data science. You can search for this keyword. This is our consulting company. But our goal is to spread the word and make sure that lots and lots of people are educated on different aspects. So go ahead and subscribe and make sure that you really pick up knowledge. Now is the question answer time, and any questions I'll be glad to answer. How can we move to ML field? So one way is by taking up some industrial certification programs, which are short programs which help you in taking a practical approach. So there are lots of certifications offered by, for example, KnowledgeHut or companies like that. So my suggestion is look at all typical data science companies, certification companies, training companies like KnowledgeHut. That's a good way, because today these companies don't make a difference whether you're coming from computer science, whether you're coming from electrical, doesn't matter. They will make sure that they will equip you with a more practical approach to data science in these certification programs. So my goal is to tell you that don't be afraid of your background. Anybody and anyone can do these programs and get certified and get into practice. How data engineering fits into the life cycle of data science and ML. So data engineering is the complementary to data science, where I said that as a part of data preparation for ML, right? There is a need to prepare data. There's a need to clean data. There's a need to make sure that data is available for running the algorithms in a neat manner. But in doing that, when you have tons and tons of data, let's say you have millions of tweets, and you want to generate neat extracted data from that to be fed into your data science analytics, which is say ML powered, the pipeline should be going through something like a big data process. Could be like a Hadoop based cluster where you run some kind of filtering algorithm run on a Hadoop data, or you can run it on maybe a data lake and run some transformations on that, where you clean the whole data before feeding into data science. So data engineering works on scaling up the whole process of preparation of data before you feed into the analytics. So that's why data engineering is required when you're running data science on large volumes of data, because you cannot do processing with simple Excel and feed into data science when you have million rows. You have to appropriately take a Hadoop or some kind of big data infrastructure to load the data, clean the data, pre-process the data, and then make the data available as a potential input for your analytics. So how to use data science in our job profile. I don't know what level you are. If you are already in the mid-management, one way of doing that is saying that, okay, let me take a tab at some company process which have data and volunteer for doing a data science based project in your organization. where if there are data, then apply data analytics, machine learning on that, see if you can improve that process. So the way you look at it is you try to see if there is good amount of data available, then view it from a lens. What is it? Is it a regression you can apply? Is it a classification you can apply? Or you do a segmentation? What kind of logic process you can apply from a different strands of process I told you, right? Which you can apply on your data in your case, and see if you can impress your management by applying data science in your actual job. If you are not from an already experienced profile, I would say try to pick up some basics of data science in one of the certificate programs, and then start looking for opportunities in your company where you can get data and do some analysis and data science. How much minimum experience needed for data science? So there are two levels which we talk about. One is called data scientist, then another is called data analyst. For entry-level data analyst positions, people are okay to enter at entry level, where you will be primarily looking at creating a good pipeline around data preparation, data curation, etc. And then for data science, which is more advanced, where you try to apply data science algorithms and patterns to actual data, they expect some business experience of 5 years, because otherwise data science application to the business data is not so easy just with raw without experience. So data analyst for low level, data scientist at a higher level. There's a lot of buzz around saying that data analytics will be automated. Agreed. Just like we are automating some process, today there is a science called AutoML, which is trying to hyper-tune the whole process of what data scientists do. But at the same time, let me tell you from my experience with AutoML, there is already a pushback in the community about black box data science, which people say is not good enough for me. When my credit cards gets rejected based on some automated decision by an AI program, I'll not be happy. So there's people talking about, can we explain why your data really took this decision? So when you're talking about such explainability requirements for your data, I think even automation will have to be broken down. Automation may speed up your overall process, but it does not deliberately remove the need for data scientists. So it will be a mixed world in the future. Some elementary tasks may be hyperparameter tuning, may be automated, but bringing rationality into it, bring a tuning process into it, fine tuning the input variables for features into the model, all that will be a lot of subject domain and data scientist expertise. So I don't believe that AutoML will kill ML jobs. In which telecom area data science has potential? Huge potential. So for example, one of the areas where I'm seeing lots and lots of machine learning done is 5G. 5G has so many configuration parameters, so many parameters to be fine-tuned that it's impossible to have a manual approach to doing rule-based configuration, rule-based routing. So a lot of routing optimization configuration is being done using ML and 5G. Then from a conventional telecom infrastructure, there's a lot of churn prediction from a customer churn which telecom companies are using AI. Then from an infrastructure level, people are using the concept of, can we find root cause analysis of where faults are happening? Which layer? Is it at OSS layer? Is it at service assurance layer? Is it at bottom layer in the network? Which layer are the more faults happening? They're doing tracing of different faults. Then they're trying to do customer service analysis of which channels are more profitable by looking at data from the real consumers who are like, say, the cable companies, and seeing what kind of programs are getting more attention. So they will do analytics on that. So there is, sky's the limit. It could be at infra layer, it could be at customer analysis layer, it could be at analyzing protocols layer and improving them. Multiple layers telecom companies are using data science. There are ML tools in the market. Should we focus on understanding how those work, or should we start coding, understand how it works from scratch? Today, as a data scientist, I think you should concentrate on what is your problem, what is your data, what is the important data. Concentrate on framing your problem first. There's no point in going into internals of partial differential equation of linear regression. Linear regression is available out of the box from any ML tool. But what is important is choosing the right variable, asking the right question, so framing the problem with right input variables, feature engineering, and right output variable. That is more important. So concentrate on that. Then you can use the tools to automatically analyze and get your results. So I would not want everyone to be concentrating on the internals of ML algorithms. That is useless. If everyone starts doing that, then there will be very little users. So I think a major requirement today is on how people can use a linear regression algorithm for actually formulating a real world regression for prediction of future value. It's not going to be like everybody will have to program the actual code. R-square generally is better because in RMSE, the accuracy of the model depends upon the unit of the output. For example, if you measure the same problem in meters and you measure the same problem in kilometers, the kilometers RMSE will be very small, whereas in meters, errors will be very high. That's why we use R-square and the adjusted R-square. For data science, what basic qualifications is required? One skill, will to learn. There is no day which goes where I don't learn. I have a PhD in AI, but I still learn a new thing every day. I talk to people. I talk to businessmen. I learn a new use case. I talk to a latest, deep learning scientist in some Microsoft research. I get to learn a new algorithm. Will to learn. That's all. I don't think everybody should be bothered about how to enter. Anybody can enter. Today we have citizen data scientists. You can actually search for it. There's a scientist in Hyderabad, in India. He's 13-year-old. Siddharth Pili. Just search for him. There was some guy called Tanmay. IBM gave him Watson certification at 12 years of age. Don't wait. There's no harm in just taking up a tool. Take up a tool like Veka. Very simple, GUI based. Feed data, you'll get output. You don't need to even do programming there. So don't think that qualifications are important for data science. It's a will to learn. Any good books to read on this? I would say internet is the best. YouTube is the best because there's so many dynamic. So YouTube, just search for machine learning playlist on YouTube. You'll get tons of potential. Or look at machine learning certification from KnowledgeHut or something like that. You can get more data. Because let me tell you, the idea of ML is changing every day. It's not like once you learn from some book, you know everything. Can you explain what is feature selection? Feature selection in ML is about if you have 100 input data, let's say x plus x1 plus x2 plus x3 is the input and you have y as the output. And suppose x1 and x2 are related. Say x1 can be expressed in terms of 0.9 times x2. Do you really need three variables? You can use x1 and x3 only. So you eliminated x2. That's called feature selection. You select a subset of the input variables which you want to get into the actual. How to increase knowledge on feature engineering? There are tons and tons of videos on YouTube. You can try feature engineering videos, guides out there, tons of them. Start with feature selection. Try principal component analysis. Try factor analysis. Different ways by which you can generate individual features as required for your target problem. How is ML by Tom Mitchell book? It's Bible. I read machine learning when I devised my machine learning algorithms in 95. When I published my machine learning algorithm, that was the Bible. But today, it turns out to be more on the theory side. So it's a good for people who want to go into internals, and it's a concise and very nice book. Same way for deep learning, you look at the book, which is the deep learning book by, I think, Goodfellow. That's another thing for deep learning. Any question which I have not answered?
I think we don't have any more questions for now. Dr. Srini, thank you so much for going through all the questions. Attendees, we have the last couple of minutes, and I'd like to introduce my colleague. Dr. Srini, with your permission, if we are done with the presentation, can I introduce my colleague?
Go ahead. Just one question I'll answer. Do you start from Python to get into AML world? Not necessary. If you are a Java guy, you can look at learning ML using Spark. So that's all I can say. You can use Python or Java. These are two prominent, or R. These are three prominent languages in which you can do ML programming for today.
Great. So thank you very much, Dr. Srini. With your permission, I'd like to introduce Kailash, my colleague. Kailash, are you there?
Hey, yes, Shruti. Yes, you're able to hear me?
Yes, can hear you.
Yes. Thanks, Shruti, for allowing me to speak, and thanks, Dr. Srini, for this wonderful session. I thoroughly enjoyed the session with other participants as well. I'll just, the reason why I'm here, I just want to quickly share my screen and let you all know that Knowledge Hut has, a few courses around data science. The first one being Python for data science, which is a basic course, followed by data science with Python as the next level, and then machine learning with Python, followed by deep learning. So I've showcased these courses in the order of uh, like a career path, which these are the courses that you can consider at different levels. All right, so more importantly, apart from these courses, we also please watch out for our communications. We would be sending email to you all about various webinars and various 1-day sessions, 2-day sessions on data science and Python, and different tools that Dr. Srini had mentioned here today in today's session. So overall, we hope that you've enjoyed the session, and we look forward to engage all the participants in the future sessions as well. So that's it from my side, Shruti.
Great. Kailash, would you like to share your email ID? I see a lot of attendees asking questions around courses. It will be a good idea for them to get in touch with you in case of any information.
Yes, certainly. So what I can do is, if you're interested, to know about any of our courses, or for that matter, any other courses, I suggest that you can write to me and I shall reply back to you. I'm just typing in my email address. Okay, I've sent my email address to all. I hope everyone is able have received it. Uh, Please feel free to write to me for any queries related to courses or webinars, or any specific sessions, any specific technology that you're looking for, you or your organization.